welcome back to the channel of Ecoholics. So in today's video, I'm going to solve a question which appeared in the paper of ISI Part A 2022. So let us get to the question. Okay, the question is from differentiation. The question gives us a utility function of some consumer. The prices are also given. The price of X and Y both are equal to 1 and the income of the consumer is 40. And we have to find the optimal value of X and Y over here. So all the answers are given in numeric, only just the last one says none of these. The thing over here is when you see such questions, our first approach whenever we see such question like I have to maximize utility subject to a budget constraint, we directly jump to Lagrange, right? Because that is the only way out here that we are given a budget constraint. I want to maximize my utility. So let me just set up a Lagrange and maximize my utility subject to that. All right. So if I try to do with that, I try to solve this question with the help of Lagrange. I'm not saying it's going to be incorrect. But the thing over here is like before you proceed some question with the help of Lagrange, the first thing you have to always do is look at the objective function. If you go here and look at the objective function, the utility function, it have a minus over here. So utility has some sort of minus sign over here, right? And if I go and have a look at the terms inside the bracket, this is square of something. So whatever is the value of X, even if this difference comes out to be negative, the square is going to make it positive. This term will also be positive always. So it means the terms inside the bracket together will always be positive. But because I have a negative in front of it, the utility will always go to negative. Now, when I solve it with Lagrange, I will get some values of X and Y, let us say whatever values I'm going to get. But because of that, I'm going to get a negative over here. So how my utility is going to be maximized? The thing is, when I work with negative number line, let's say over here it's 0, minus 1, minus 2 and over here I have minus 10, let us say. So if you work on this number line, although when you go from here to the left side, the numbers are increasing. In the magnitude they are increasing, but by values they are decreasing. So the numbers, the value of the numbers is decreasing when I come to the left hand side. So when I'm working on a negative number line, 0 has to be the greatest value because positive it can never be. This utility function can never be positive. The maximum value it can attain be 0 because after that whatever value it is going to attain, it is always be on the negative side. So 0 will be greater than all the negative numbers I have. So when it is going to attain 0, it's going to attain 0 if and only if X is also 10, Y is also 10 because 10 minus 10 and 10 minus 10 their squares are going to be 0 only. So let us solve this question then. Alright, so only when X is equal to 10 and Y is equal to 10. The 10 minus X square which is going to be 0, again 10 minus X square which is going to be 0. So 0 ka square is 0 and I get a 0 here. So if I put any other value, let us say I try to put 20 here. So 10 minus 20 minus 10, but minus 10 ka square is 100. Similarly 20 here, so 100 plus 100, 200. So I get minus 200. When you will try to solve it through Lagrange, you are going to get X equals to Y equals to 20. So that is not going to maximize it because of the presence of negative sign over here. So let us see, are these values satisfying my budget constraint? So my budget constraint will be like this. So price is 1, X is 10 we are saying, price is 1 again and Y is also 10 over here. This has to be less than 40. So 10 plus 10 is 20 which is strictly less than 40. So these values of X and Y are satisfying my budget constraint. They are also maximizing my utility. So over here in this question, I have tried to solve this even without taking the help of Lagrange. So the optimal values of X and Y are going to be 10 and 10. So option A is my correct answer over here. So this was the solution to question number 9 of past year 2022 from ISI. If you want to see more such videos, please subscribe to the channel, like, share. Let us know in the comment section below that which all topics you want us to make videos. Thank you everyone for watching.